my name is Magda. I'm a Scala developer at Software Mill, and I'm very happy to be able to be here today and talk to you about implicits in Scala 3. So, to start, I have been a Scala developer for 7 years now, and right now I can say I like it. I enjoy writing Scala every day. But it wasn't like that the whole time. In the beginnings, I was really struggling with understanding the various concepts in Scala. And one of the things that confused me the most was implicits. There were times when I thought, okay, I got this. I finally understand implicits. But then a week or two later, I came upon some other use of implicits and I was totally lost again. So I had to go back to my more experienced colleagues and ask them, sorry, I know we have already talked about implicits, but can we please sit together one more time? And can you explain to me what happens here? What is trying to be achieved in this piece of code using implicits? Fortunately, my colleagues were very patient. So I got through this difficult phase and I didn't give up Scala altogether. But it was close, I must say. But I kept thinking, why does it have to be so difficult? So when I heard about Scala 3, and I heard that the concept of implicits is going to be worked on in Scala 3, that got me curious. I wanted to know if maybe this is a change for the better. So this is how this presentation was created. I would like to share with you what I have learned. So the plan for the next half an hour is I will tell you why implicits are important, why do we need them in the first place, what are the problems in Scala 2 with implicits, and the main part of the presentation will be 7 use cases where I will show you the old code, the Scala 2 code, and Scala 3 code, so that you can see how to achieve the same thing using the newer version of the language. And then I talk a little bit about migration. So what are implicits? Why do we need them? Generally, in Scala 2, the implicit keyword can be found next to various language elements. And you can use it to define many different things, to achieve many different goals. But what's common is that they define so-called contextual abstractions. So when you write your code, it doesn't exist in void, it exists in some kind of context. And then you can decide that because of that, you don't have to write everything explicitly. Some of the things you may let the compiler infer from you, infer from the types. So that's why it's called contextual abstractions. So this providing context is the main area why we need implicits, but because they are a very powerful feature of the language, they can be used to achieve other things as well. So they are also used widely in Scala and in libraries to things like adding functionality to your code, to your types, to define type classes, which in itself are a very important and powerful feature, to provide implicit conversions between the types, to provide dependency injection, express capabilities, compute new types, and prove to your compiler some relationship between the types. So for all those goals, for all those needs, you can use implicits. So they are powerful, they make us powerful because they let us do with our code what we need to achieve. But at the same time, they can also make us miserable. And why is that? In my opinion, the most important problem is that you can find the implicit keyword next to parameters and arguments, values and objects, methods and classes. So it's not like you see the keyword and you instantly know what is being achieved. You have to have some experience, you have to know the idioms, the patterns, the ways of solving things in Scala to understand and recognize what is being achieved in the piece of code that you are looking at. So it's not clear just from the keyword. But also there's a problem of imports. So personally, I have spent hours trying to chasing the right import. Because sometimes you have one class and it compiles, it's fine, and then you copy some code to another class, another piece of code, and there it turns out your code doesn't compile. And often the problem is that you are missing an import, because in the first class you had a long list of imports, and one of the 20 imported or fetched into scope some kind of implicit that is needed for the code to compile. So you need to scan this list of imports and guess, is it maybe this import, is it that import? Let's try this and maybe it will magically fix our code. Or even worse, you remember that sometime in the past you wrote this code and it compiled and it worked. And now you are trying to fetch it from memory and you don't remember the import and you don't know how to find the right import. You know that it exists somewhere, but you don't know what it is. So this was a problem for me. And another problem sometimes can be that you try to import too much. Or rather, you don't try, but somehow too much is imported. And this is a problem with implicit conversions in Scala 2, that sometimes in the long list of imports, some of them may fetch something into your scope, which made your code behave weird, because then your compiler treats some type as some other type because there is an implicit conversion in scope. Or maybe you are too eager with your imports, you import too much, and then again it's an ambiguous import, ambiguous implicit for the compiler because it can have more than one to put. So that's part of the problem, why for me Scala had definitely a steep learning curve. So now, how is it different in Scala 3? So Scala 3, as you probably already know, is kind of a major language rewrite. Not in terms of migration, but in terms of the concept in my mind. So actually, it took, I think, 8 years from the first commit to the general release of Scala 3. And what's most important for me, what's most significant, is that the creators and contributors, they have set on a mission to listen to us. So to see how Scala is being used, how libraries, how projects are written, what are our comments, what are our concerns, what are our questions. And they were on a mission to fix the tricky bits for us, to address the pain points and to make Scala a language which is easier and more convenient for everyday use. So by now it's probably not a surprise that implicits have been discovered as such a pain point, which was decided to be redesigned. And it's redesigned to the point where the implicit keyword is gone altogether. You don't really find it in Scala 3. So what do you get instead? Instead, you get a couple of new language features, and each of them does one thing and does it well. So let's see what those are. I will show you 7 pieces of code, 7 needs that I sometimes try to address, 7 issues, and we'll see Scala 2 versus Scala 3, how they compare. So that's the most important feature, providing context. The second one, we will add some functionality to types. Then we will show how to define type classes in Scala 3. I'll talk a bit about implicit conversions, and then we'll talk about imports, unused names, and compiler errors. Let's start with the most common and most important need, which is to provide context. So in Scala 2, if we want to have the code like below, this is really what we need. We want to define a future, and there's a body of the future. So that's what we want to write. However, we know that if it's some kind of asynchronous computation, it's not enough. So we need to have some kind of thread pool, or in this example, an execution context. So this is something that we may want to infer from the context and not just write explicitly in every future that we define. So the way you do it in Scala 2, if you take a look at the definition of the apply method of the future, apart from the first parameter list, it has another implicit parameter list, which defines that here you may provide this executor. And how do you provide it in your code? You just have an implicit value, and then you say execution context global is what we need, what we fetch, and we tell the compiler to just fetch it where it needs it. And by doing this, we can achieve what we want at the bottom, which is the clear definition of the future with just what should happen in the future. So that's Scala 2. We see the implicit keyword. How is it different in Scala 3? Here we want to achieve the same thing, so we want to have at the bottom the definition of the future with just the important parts for the reader. Now, if you look at the changed definition of the apply method in the future, you will see the new keyword. It's again a second parameter list, but here you have this using keyword. And in the place where you actually provide the execution context, you have a given. So instead of one implicit keyword, you get two new keywords. It's a pair, using and given. So where you define, you say that this method is going to use some context, in this case an executor, and where you provide, you are giving it. So this is the most important and something that you will use the most in Scala 3 when working with contextual abstractions. So that's something to remember. But let's move on to adding functionality. Now, to describe it well, to explain it, let's imagine a sample domain. Let's say that we are working with providing social website for people who like to read books, so that you can add the books that you have read, you can add the books that you want to read, and there's also a thing called reading challenges, so that you may want to define at the beginning of the year that this year I'm gonna read 10 books or 20 books and see along the way if your goal is met. So that's all fine and it's working, but let's imagine our product owner comes to us and says that there's a problem because some of the users add really short books, like 5 pages long books, and they have these enormous reading challenges which they finish too early, and it's not so much fun. So we need to add a new method, this qualifies for challenge method. So what we would like to do is we would like to decide whether a given book qualifies for a challenge if it's longer than 20 pages. However, our problem is that our book type exists somewhere else in another package. It's a closed type, it belongs maybe to another team, it's imported from somewhere. We don't have control over it and we cannot really add methods to it, but we would really like. So what can we do? Of course, with Scala you can achieve many things. So you can also add functionality to a closed type. And in Scala 2 you do it using an implicit class. So that's how you do it, you define it, you give it a name, even though it doesn't matter. It operates on the book type, and then it has this qualifies for challenge method. The definition of the method is that if the number of pages is greater than 20, then yes, the book does qualify. So again, we have the implicit keyword used for adding, in this case, for adding functionality to a closed type. Now let's see it in Scala 3. We want to achieve the same thing, so we want to have the code as below, which is just the same. We want to have this qualifies for challenge method, and at the top we have the closed type, so nothing changes here. But how do we achieve it in Scala 3? We have a new keyword. We have an extension keyword. And this is a good example of a thing which does one thing and does it well. So we have the extension defined on the type book, you define the qualifies for challenge method, you define the body. And as you see, the syntax is very simple. And the next time you see the extension keyword, you will probably instantly know what the author of the code is trying to achieve. They are trying to add some method to an otherwise closed type. The syntax is clear, so even maybe next time you won't need to go back to the docs, you will just write it from your memory. So that's an example of an improvement for the best, in my opinion. Let's now move on to something more complicated, type classes. So as I said, type classes are important in Scala and in some other languages. So why may we use it? Actually, it took me, I think, 5 years from my first writing Scala until I felt the need, okay, I need a type class here. So it's maybe not something you do on your first week writing in Scala, but it can happen. Let's imagine that we are still in our book website domain. We have books and we have our reading challenge with a score. But it turns out some people come to us and they say, we don't really read such a lot of books, but we read a lot of articles on the internet or in magazines. And we would also like to take part in your challenges. But how do you compare? Reading 10 books and reading 10 articles is really something different. So let's imagine we want to add a scoring mechanism so that we would have a code like below, where let's say we have Dune, the book read, and then the current score, if we add this book, is 600. But then we can have an article type, a new article type, and if we add it, then it increases our score with a 1. So every article is counted as a 1. So how can we achieve the code like below? If the article and the book had a common parent, then maybe we could consider adding a method to this parent, maybe a trait, and then each of the classes would implement this trait with its own behavior. But it turns out that book and article are totally unrelated types in terms of type hierarchy. So again, we have no control over them, we cannot let them define and extend any traits, implement any traits, and so on. So for this, we might want to use type classes, because what we want to do is we want to add so-called ad hoc polymorphism. So give common behavior, define common behavior to unrelated types. And for this, we can use type classes. In Scala 2, the way we do it is we define a trait, and this is our behavior. In this case, it's our scorable behavior, parameterized by the t-type, and the behavior is to have this score method. And then we have using implicit vals, or actually it can be implicit objects or defs, but here vals. You define the behaviors for each of the types. So we have the implicit val for the scorable behavior of the book type. And you see the implementation of the score method is the number of pages. And similarly, we have implemented the scorable behavior for the article type, where the score is always 1. And the way we could use it is here in this case class current score, where the add item method is parameterized by t::scorable. It's called context bounds, and it means that this is a method working on an item, on any item, any type which has the scorable behavior. And the way we use it for if we are adding an item, we are taking the current value of the score, and with this implicitly of scorable, we are telling the compiler to fetch the right implementation of the behavior according to the type that we were called with. And if you don't like this implicitly of scorable, there's also another way to write it. You can have another parameter list. It may be something you prefer. There's an implicit parameter list where you have this scoring parameter named so that you can use it here in the scoring.score. It's just a named parameter. So that may be something you prefer. So that's how you do it in Scala 2. And that's why you may need type classes at all. And now in Scala 3, of course, you can also implement type classes. Our desired behavior is again at the bottom, nothing changes there. And the definition of the behavior, the trait, is also the same. And how do we implement this behavior? We use the given and using pair again here. So where we provide the behavior, the implementation of the behavior, we use the given keyword, and we have the scorable behavior for the book and the scorable behavior for the article implemented. And where we use it, again, we have context bounds, so that doesn't change. We are adding any item which has the scorable behavior. And then instead of the implicitly keyword, we now have a new summon keyword. So even for such a small thing, this has changed. The implicit keyword is not part of the implicitly keyword because this doesn't exist either. So we have this summon keyword. So we tell the compiler to summon the correct implementation of the behavior that we want to use. And also, we can have consistently the other way of defining that. So that's with an implicit parameter list. But here you will have this using keyword. And again, you can call the method on your scoring item. So that's how type classes look in Scala 3. Now let's move on to implicit conversions. Why we may want to use implicit conversions? Maybe they're kind of controversial because of the problems I mentioned earlier, that sometimes it's a bit too implicit, that the compiler treats one type as the other type. But let's say we need it. Let's say we have our book type and we would like to print it. And we have this print method defined at the top. It's this beautiful and special way of printing that we would like to use. But there's one problem. This print method operates on an item type, and we are working with book type. And again, the item type is closed, the print method is closed, and we would like to somehow overcome this. So what do? In Scala 2, we can define an implicit conversions conversion with an implicit method. So we call it book to item, whatever name. It operates on the book type and returns the item type. And the definition of the method is just to use the constructor. And if we have such an implicit in scope, then the code at the bottom compiles. So we can have the print method. The compiler knows how to treat book as an item. And how do we achieve that in Scala 3? Again, the code at the bottom and at the top is the same. But to provide the conversion, there is a special Scala.conversion class that you need to extend. It's a class defined just for that. It's parameterized by the source and the target type, so in our case, book and item type. And then the apply method applies the conversion for you. And the definition, the body of the method, again, is the constructor. So again, here, this is a thing which does one thing and does it well. So whenever you see the Scala.conversion class in your code, you instantly know that it's an implicit conversion. It's not anything else. So in Scala 3, it's almost as it makes implicit conversion a bit more explicit. So that makes it less confusing. And now if we're talking about confusion, let's talk about imports. So my nemesis of trying to find or guess the right import. In Scala 2, such a code would compile and work just fine. We are importing everything asterisk from this package or object, and then our future compiles. But in Scala 3, this would give you an error, the same code. And that's because in Scala 3, asterisk means import everything apart from given instances. So import only the explicit stuff. And if you do want to import the given instances, you need to use the .given syntax. So that makes it a bit more explicit in the long list of imports, which imports actually import some givens for you. So it makes it easier to find. And if you do want to import really everything, then you can use this given, comma, asterisk syntax, and then you really import everything. But you see it, you see instantly what happens here. And now there are also unused names. So this is one of my favorites because it's a really small improvement to the language, but it makes everyday life so much easier. So in Scala 2, the names of the implicits were mandatory. Let's imagine we have our books, we have a sequence of books and we would like to sort them. So in order to not reinvent the wheel, we are using the seek_obstrate with the sorted method, because we want to use it like below. But if you see at the top, there is this implicit parameter list with the implicit ordering, because we need to tell the compiler how we want to order the books. Is it according to the name, according to the number of pages, or something like that? And in Scala 2, you again use the implicit value, and you say that this is your ordering parameterized by the book, so this is your ordering of books, and the implementation is for 2 books, we just compare the titles. So you need to think of this by title name, but if you see below, we are not using it really, right? Because for the compiler, it's enough to see the types. If it has the implicit with the correct types, it will just use it where it needs such types. But still, we have to think of this. And in Scala 3, we are using the using and given pair again, and we can provide the name of the val, but we don't have to. So we also can have the syntax like below. And this is all we need. This is all the compiler needs, because it knows that we are providing an ordering for books with such a definition. And we also maybe don't need it. So then the decision is ours. Do we want to give it a meaningful name? Or do we want to omit it? This is just one more decision that you are making in your everyday coding. And naming things is hard, so why lose brain cycles for that? You can just omit it. But if you want, you can say that this is your meaningful name that you provide. And you could see it also in the previous examples that some of the names had to be provided even though they were not used by the compiler. And if we are talking about compiler, let's also talk about compiler errors. So in my quest to find the right import, in Scala 2, the compiler was trying to be useful, but not too much. If you see the error message here, it says, could not find implicit value for evidence parameter of some type. So I know what is missing, but where? And sometimes it's easy, but sometimes if you have a long chain of method calls, you really don't know which one needs the import. And I know that there is a shortcut in my IDE which tells me, shows me implicit needed stuff, but I never remember that shortcut. And if I go to the internet to find the right shortcut, I'm already distracted and I don't know what I was doing in the first place. So this is again a small thing that you trip over in your everyday writing Scala life. And in Scala 3, the compiler error is much more helpful. So it says no implicit argument of type scorable was found for parameter scoring of method add item in class current score. So we know which class, which method, which parameter. So that makes it much more easier. And sometimes the compiler will try to be even more helpful. So it might suggest some imports for you. And sometimes it's not what you want. But sometimes when you're hacking away, you are in a hurry, you just want to make it compile, you are writing an MVP, yes, it's okay for you. Just use the default implicits.global here in this test or in this, I don't know, throwaway code that you are writing just to prove something. So that's a small thing, a small help which makes your daily Scala writing a bit easier. So that were the 7 examples. And now, how do we go about migration? Because when I said it's a major language rewrite, then does the migration also happen to be major? And if I say that the implicit keyword is gone, then do we need to make a big bang rewrite, which means we will never do it because it's not worth it? Actually, it's a bit more easier. So in general, Scala 3 is somehow backwards compatible. So a lot of your Scala 2 code will compile in Scala 3. And there are also some compiler flags which let you tweak how much you want to rewrite and some automatic rewritings. But in terms of implicits, I said they were gone, but actually you still can use them. So you may, for example, have your code fully migrated to the using and given, but what about the libraries? You can use the libraries which still use the implicit keyword with your migrated code. Or maybe your code uses implicits, but you are trying to use a new library with the given and using pair. So you can do it interchangeably. The compiler will translate it for you, so you can use both at the same time, and you can perform the migration on your own pace, just switching from implicits to given and using to the new implicit conversions and so on. So in theory, you don't really need to get rid of your implicits. But why stick with the old ways if we have the new features which make your code more easier to read, actually easier to reason about, which is what we love about Scala. So that's this interoperability, which makes you do the migration at your own pace. And probably sometime in the future, the implicit keyword will be deprecated. I am not sure when, I haven't found such an information. I also hear people who say it will never be deprecated because it's such a core feature of the language. We'll see. But for now, nothing stops you from using the implicits or using the new, nice, shiny things that we have. So to sum up, what I love most about contextual abstractions in Scala 3, although it's hard to love implicits and the complicated stuff, is that they let you write the intention. I like to think of writing a code as I'm writing a book, I'm writing a story, and then someone else comes and reads it. And then they know what my goal is, what I'm trying to achieve here, and not how I am trying to achieve it, and what language features I am using. So this is something that I love about the implicits in Scala 3, is that they let me write what I want to write. So I think that's also, in my mind, consistent with the functional programming being a bit more about writing what and not writing how. So the given using pair is something that you will use most often, but other tools and features in your toolbox are now the extension methods, so a special keyword just for that, and the Scala.conversion class, which is used to convert between the types. If you'd like to know more, there's also a feature called context functions, which I haven't mentioned because it's a feature of Scala 3 which doesn't have a direct counterpart in Scala 2. So that's something new which you might want to have a look at. If you'd like to see the docs, the reference, you will see all the small print about what will compile, what won't compile, what you have to fix right now, what you can fix later. And also with the migration guide. And here are the two repositories of the codes from this presentation. If you'd like to play with them, see how the compiler behaves, you can have a look. So that's all I had. If you have any questions, I think we will have time for that. If you have any comments or feedback, I am waiting for that under this QR code and under this bit.ly link. And one more thing is, at Software Mill, we are organizing the Scala conference in March next year, but also a new Rust conference. If you're interested, you can use the Magda 10 code to have 10% off the ticket. So thank you. Are there any questions?
Yeah, hello. Yeah. First of all, before we under talk, I had a question about one of the imports. So in Scala 3, if I understand correctly, all given definitions, or like implicit definitions, are imported with the .given. But then for the execution context, you imported .global. I'm just confused.
Oh, sorry. That's this implicits.global that we saw there is just the name of the given instance in that package. So I actually imported directly the one given instance that I needed.
Okay, thank you.
Thank you for the question.
Thank you for the comments. What if you want to specifically import a given that you define without a name? Is that possible?
That's a good question. I know that those givens are given a default name which you can use, but in my mind that would be a bit confusing. So it depends. If you control it, you may want to give it a name actually, so that it's easier to import, or you can use the automatically generated name, or you can just use the .given to import all of them.
I think you can also implement type.
What can I import?
If you have a given for ordering, you can import it. Import something that ordering. Right there. So even if it's unnamed.
I'm not sure what that is. So that I import the ordering, and then what is the problem? I'm not sure what backtyping is.
If you have like given or column ordering in some package, then you can import that package dot ordering. Right there.
Yes.
So.
Okay. Maybe if someone knows a better answer than me, then we can say that out loud.
Just to make sure that I understood correctly, what we're saying is that if you have an anonymous given value, you can import it instead of referring to the model-generated name, importing it by putting the type of the implicit value, and that will import it's a given, even if it doesn't have any. You can just use the value that the type referred to it. Is that what you meant?
You mean in the import line to use the type?
If you have an negotiator, you can just use. Yeah, that's what I understood.
I don't know. I don't know. Does anyone know? Can we do it?
Yes, I follow the syntax that you can do it. It's real and we have to explain this.
Okay, good. So now we know it does exist, but we would need to check how it looks like. Thank you for the question.
No more questions? Thank you very much.
Thank you.